Okay, folks, we're going to look at climate change. And we know a little bit about climate. We know the different regions that are warmer are going to have more people in it. Severe climate causes additional change challenges to everyday life, and we know that about Alberta. Okay, for example, the clothing we've got to wear. Think about it. We go from potentially minus 40 to plus 30 degrees Celsius. Where on earth do you have a 70 degrees Celsius change in temperature where you've got to wear extremely cold clothing and then very light clothing as well? Okay. And think about that impact on the heating and the fuel we're going to need. What would happen with a furnace if we didn't have a furnace? When my Australian exchange partner, Miss Maurice, came here, we had to talk to him about a furnace and how that worked. It was very foreign to them. Okay, the type of food we eat. Okay, the fact that we got to bring our food from places like Mexico. Okay, places in Australia don't have to do that. So we're very interdependent with other countries as well. Okay, now when we talk about climate impacting organisms, though, those adaptations are very different than us adapting as humans to the climate where we've got to wear warmer clothes. That's a different form of adaptation. The adaptations in nature, say of these two plants here, any change in the structure or functioning of an organism that makes it more suited to its environment, they have adapted to water. In both cases, there's low water. There's low water because of all the salt by osmosis sucking water out of this tree, this palm tree. So it's got to have mechanisms to prevent water from being lost. But then this arid air for the cactus makes water loss through evapotranspiration very high. So it has to have a thick, waxy cuticle, which we learned about in the last unit, which is part of the epidermis. Okay, plant life in Alberta. Okay, plants go through a period of dormancy, which don't in places like Australia. Okay, it's because when the water freezes, so does the xylem and phloem. So they go into periods of dormancy. Deciduous trees lose their leaves, like poplars, to maintain conserve water. Okay, plants in Alberta flower seasonally. Plants tropical areas don't undergo those periods of dormancy. Okay, with climate affecting animals, key part is food supply. So a behavioral adaptation of this grizzly would be hibernation. A physiological adaptation would be putting on a lot of weight. Those would be two different types of adaptations that allow it to survive in a cold climate. Contrast this to animals in warm regions. They can be cold-blooded, okay, reptiles, okay, seeks out sunlight when it's too hot or cold for shade, thick water-resistant skin to protect it from warm, wet water climate, are active all year round. Okay, now we're going to get into climate change. Now we know that we've got to have at least 30 years. Some scientists would say a lot more to actually look at whether the climate has changed versus the day-to-day weather business. Okay, and we're going to look at some evidence for that. This fellow here is doing what's called ice core drilling. The oldest ice is here. The youngest is here. In that ice is trapped gases like oxygen and carbon dioxide. Okay, and they can actually radiocarbon date or radioisotope date rather these gases, particularly the oxygen. Okay, and that tells them how much carbon dioxide in the atmosphere, and then they can monitor whether this greenhouse gas has changed over time. Okay, so Earth has experienced climate change a number of times in history. climate becomes cooler and warmer. Today, the average surface temperature is increasing, and this is based on anecdotal and scientific evidence. Anecdotal is just telling stories. There's no what we call baseline data. And you can find this in farmers. Farmers are out on their fields every day. They know when to plant, they know when to reap their harvest. And is that changing month by month? Each year. Well, you talk to a 60-year-old farmer, 70, 80-year-old farmer, they can tell you a lot of changes over the years. Aboriginal Inuit elders. So Inuit, Aboriginal people, traditional ecological knowledge. The Inuit hunters will tell you that the sea ice has changed over the decades. And so it's much more dangerous to go out hunting now than it was when they were children, say in the 1950s. Now, this data does not have what's called base line. There's no baseline data to it. That means an Inuit elder might say that the ice is thinner, but by how much? They didn't actually take measurements when they were children, 1950s. Okay, so scientific evidence collects this baseline data, involves data. Baseline data we can compare and measure. So in Canada, we try and combine tech with the scientific evidence. We try and work together with different communities in Canada. And the two tend to merge, say that has been. But again, this is over a very short period of time. Remember that. Interpreting data, graphs, okay, we use. Not all regions in Canada experience some same variations in temperature, which makes analysis even more difficult. Okay, so graphs collected data sometimes makes it difficult for scientists to detect changes in different regions. Think about the difference between Edmonton and Calgary. Calgary gets Chinooks. So even though it's only 3 hours away, their climate is different than ours. So how do you measure climate change in two regions that are very close? Well, now compare Edmonton to Timbuktu. Our climates are someplace on the other side of the world, very different. How do you get average temperature changes over thousands of years? Very tricky. Okay, so we are going to interpret some graphs, and then we're going to get into interpreting graphs. In ways of interpreting, we get circle graphs when you look at data that is part of a whole. Average teenager's day, that's the whole, and there's parts going to school, other stuff, and sleep. Bar graphs are good when the manipulated variable is a category. Transportation, electric power generation, industrial fuel, these are categories. Line graphs is when both manipulating and responding are changing at the same time. The year is changing and the temperature is changing. Climate graphs combine both bar and line graphs. The bar graph is precipitation. So whether it is in January and February, oh, June, July, August, this precipitation will mostly be rain. In November, December, January, this precipitation will mostly be snow. Okay, and we would read it, the bar graph part over here in precipitation. The temperature is going to go from 4 degrees to 18, average temperatures in Vancouver, and that would be the line graph. Okay, I want you to do these questions. And question 8, I want you to try using your computer to put it on a Microsoft Excel spreadsheet. And from that spreadsheet, try and graph it and then answer the questions and submit these through Google Assignments.